Hello everyone, welcome back to another video. Today we will solve medium level task that called UniQ binary search trees 2. So firstly, let's start from the description of our task. Here we can see, given an integer n, return all the structurally UniQ BSTs binary search trees which has exactly n nodes of UniQ values from 1 to n. Return answer in any order. So it seems easy, but to implement it as code, it will be a little bit harder. Here we have first example, where we have binary trees 1, 3, 2, 1, 2, 2, 2, 1, 3, 3, 2, 1, and 3, 1, 2. So our input n is 3, and we will get this output like 1. It's first 3, and after we will see second, third, and fourth, and fifth 3. When our n equal 3, we will have 5 3s. So another example, if our input equal to 1, we will have just 1 3. That can consist only root of this tree. Yeah. So to solve this, I will firstly explain it. Firstly, we will, for all possible root of 3s, from 1, 2, 3 to n, yeah, get the list of left subtrees and list of right subtrees. So we will do it recursively. Now every left and right subtree combination create a new tree and add resultant list. Here start is bigger than end, and it becomes the base case for recursion, for which I add no value as element of list, which will form the only possible left or right subtree. To understand why this works, we will check it by n equals to 1. And when n equals to 0, it will handle it separately. Science lit code expects an empty list rather than a list with no value. So let I show you our code. Firstly, we will create a 3-node function, generate trees, and it will looks like this. So its first part, firstly, we will check if our start more than end. If it's, we will just give no value, and we will return result. So in other cases, we will divide it to left and the right subtrees, and as you can see here, we will give to the right subtree right values and to the left subtree left values. So it will, and finally we will return a result. So let's write this code and let's see how it will looks like in our compiler. Let's start from this function. If our n is equal to 0, as I mentioned before, we will return a new array list. We will use this one here. It's array list of 3 nodes. So else we will return our function generate trees with arguments 1 till n. So let's create this one. It's also list of 3 nodes. And it's called generate trees. Okay. Here we have start, and here we have end. Firstly, we will create list of 3 nodes that will called result. It's array list with 3 nodes. If start more than end, we will just make our result null and return our result. So, as I mentioned before, it's for our recursively method. So, let's make our for loop, and it will be look like this one. It will start from our variable start, and we will do it until end. So I++ below we will see this code. Here we should create left tree node, and here we will again call this method, but here our method will start from variable start and end with I-1. So also for the right subtree we will do same, but it should start from I+1 till end. So it has similarity with merge sort. Yes. Okay, and finally, after merging this our tree node to the left and the right subtrees, we will make for each for the left subtrees, and same thing to the right subtrees. So let's do it by this method. So okay, here we will give to the left subtree value of the left, and to the right value of the right. Root left, we will give value of left. Root right, value of right. So okay, cool. After we will add this root to our result. So I think it's done, and finally we should just return our result, of course. So let's do it here. Return result. What we will have here, Okay, two test cases passed, and let's submit. Oh, it accepted. So, thank you for your attention, guys. That is all.